we are going to now solve triangles. Now, what does it mean when a triangle is solved? That's when we know everything about it, all three sides and all three angles. So we're going to use, in order to solve a triangle, we're going to use the skills that we already know. I have that in the next slide here. What do we already know about a triangle? We know that angles in a triangle always add up to 180. So if you know two of the angles, you can find the third one by just making sure that they all add up to 180. If you know two sides of a right-angled triangle, you can use a squared plus b squared equals c squared. So now 1 and 2 are things that you already knew from grade 8 and grade 9. Those are properties of triangles from the past. Now we can add part 3 to this, that if you don't know enough to do all of the angles or all of the sides from previously, you can now use SOHCAHTOA for anything else. And sometimes you'll start to find that you like SOHCAHTOA better than a squared plus b squared equals c squared anyways, and you might use SOHCAHTOA twice rather than using a squared plus b squared equals c squared. You have some choice. So what does that look like in a question? The question says, solve this triangle. And so you have to make a decision what you want to solve for first. We need to find little m. We need to find angle n. And we need to find angle k. Those are the three things we need to solve for this triangle. And as you can see in my notes already, what I'm doing is I've color-coded things so that when we write our notes, when we solve for m, we'll use green so we can easily see when we're doing the different parts. Sometimes in your own notes, you might like to color-code things because when you're studying, that can help you picture what you did and the process that you did to make that work. So now we have a little bit of choice because there's more than one thing we could do to start. So what I want to do first of all, I'm going to write out our definition up here, SOHCAHTOA. We also have a squared plus b squared equals c squared. And I'm just going to walk through and say, is there something we have to start with? Or could we figure out anything first? For example, let's look at the green m. Is there a way you could figure out the green m?
Yeah.
What would that be?
0.
You could use a squared plus b squared equals c squared to find out the green m. Good? Excellent. Let's look at the blue angle n. Is there a way you could figure out the blue angle n? We know the opposite side of n, and we know the adjacent side of n. So because we know the opposite and the adjacent, we could use the tangent definition, and we could solve for n. And with the purple angle k, we know the opposite for k, and we know the adjacent for k. Are you okay if I label m as the hypotenuse? The hypotenuse never changes, but the opposite and adjacent can change depending on which angle you're looking at. So in this question, we have choice. It doesn't matter which one we choose to solve for first, because we just went through each one and figured out there's a way that I could solve for each one. Okay? So which one would you like to solve for first? You get to pick. What's that? M?
N.
Angle n? Okay. So if we picked angle n to solve for first, what would that look like? Well, we know the opposite side and the adjacent side, so we would set up our definition for tan. Opposite is 7, adjacent is 11. We set up our definition for the tangent ratio, and then we decide what do we have to do here. We want to solve for angle n. What's in front of the n is a tan. How do we get rid of the tan? Tan inverse. So if I take tan inverse of both sides, it'll get rid of the tan on that side. On this side, we will get tan inverse of 7 over 11. Go to our calculator. Tan inverse of 7 divided by 11. And our calculator says, well, if you have that ratio, the angle has to be 32.5 degrees. Sometimes after I've solved something, I like to write it into my triangle because that lets me look at it and say, what else do I still need to do? Well, I still need to find angle K, and I still need to find side M. Can you see with angle K, you now have two choices to find angle K. We could use tangent to find angle K, or since we now know two angles in the triangle, we could make all the angles add up to 180 degrees. One of the things that's important to do in a question like this is to think about all of the options, and then generally what we like to do, because we're an efficient kind of society, is try to decide, well, for me, which way would be the fastest? For angle K, do you think using the tangent definition and doing exactly what we did in blue would be fastest, or do you think that adding up to 180 would be fastest? Adding up to 180? Okay, so we'll do angle K next. And I'm going to write out that K would equal 180. You'd have to subtract 90, and you'd have to subtract 32.5 degrees. And some people will just do the 90 minus 32.5 degrees. And we get angle K is 57.5 degrees. And now that we've solved for angle K, the only thing we left is M. For M, we could use a squared plus b squared equals c squared. Can you see also that you could use sine, because M is the hypotenuse? You could use sine with the purple angle and go 11 over M. Or you could use sine with the blue angle, and it would be 7 over M. You could use cosine with the purple angle and cosine with the blue angle. We now have 5 different options to solve for M. And you just have to choose one of them. Which one do you want to use? You want to use cosine? And which angle do you want to use with cosine? You want to use angle N with cosine. So we would have cosine of 32.5 degrees is equal to, oh, I like this. So now, which is the adjacent side? Because cosine is adjacent over hypotenuse. What's the adjacent side to angle N? Is it the 11 or the 7? It's the 11. What do we do when we have our M in our denominator? We have to take that extra step and multiply both sides by M. To get it out of the denominator. So now we would have, oops, that's not green. Now we would have M times cos of 32.5 degrees is equal to 11. And to get M by itself, I would need to divide both sides by cos of 32.5 degrees. That will simplify here and cancel those out. And now I've got M by itself, so I can go to my calculator and go 11 divided by cos of 32.5 degrees. Enter, and we get 13.0 for M. Was there units in this question? Centimeters. Solve, give to the nearest tenth. See how I'm reading my question again? Now, I did something on purpose on this question that may have made this one a little bit off. I'm not sure if it is a little bit off, but I may have made a mistake with this one. Do you know what that mistake could have been? Right, I used the 32.5 degrees in my calculation, which was an approximation. So it could be that my decimal place is off, and I could possibly lose a half a mark here. Sometimes you're going to get lucky, and your rounding will stay the same. So now we're going to do the question with the exact value. And could I have done that on my calculator? I could have had 11. Actually, I'm going to reenact right from, so here's a reenactment. You figured this out first, you got 32.47. You went to your next step, which we wanted to write 11 over cos 32.5. You went to your fraction, you went 11 over cos, but instead of writing 32.5, I want to use this answer from before. Your calculator has that built in above the negative sign. I can go second answer, and then it will get all of those decimal places. Does it make a difference? Comes out to 13.03. We were lucky. If it came out to 13.05, then it would have needed to be rounded up to 13.1, and we wouldn't have been lucky, and we would have lost a half a mark for rounding early. So something to look at in a question like this, and I am going to suggest in this question, using the green to figure out M, using the 32.5, sets us up for that possibility of a rounding error because we're using something we solved for earlier. If we used a squared plus b squared equals c squared, can you see that the side lengths that were given to us were already given to us? They're exact numbers. Anytime you can use stuff that was given to you originally rather than your rounded value tends to be more accurate. So if I went 7 squared plus 11 squared equals c squared, 49 plus 121 equals c squared. This gives us 160. 170, thank you. 170 equals c squared. If we go to our calculator and do the square root of 170 and push enter, two things I want you to notice. I want you to notice that this number and the number right above it are identical. So it doesn't matter if you're using your exact values and all of your decimal places. The technique doesn't matter. It comes out to the same thing, which makes sense because it's solving the same thing. But I find that it really is quite beautiful mathematically that it works out so perfectly like that. That it is exactly. And from here, once you round, you would get 13.0 centimeters as well. Our second triangle, okay? I want you to try this one on your own. If you can, color code things that you can solve for. So we've got angle J, do that in one color. Little side G, do that in another color. And little side J, do that in a third color. Once you've solved your triangle, compare with the person beside you. This row will go diagonal. Okay? Compare with the person beside you. See which order they chose. See if it matches with yours. And then check your answers, because it shouldn't matter the order. You should get the same solutions. I decided to solve for the blue one first. My guess is most of you probably figured out the green angle first, because the green angle is probably the easiest, because you had two angles. You could add up to 180. For whatever reason, I used cos, and I had to use a rounded value, so my green solving here, I would say, is not necessarily the best choice. And when I got 51 perfectly as an answer, I was like, oh, isn't that pretty? And then I was like, oh, that means I probably could have done it an easier way, which was using the 180 degrees. Okay? I don't know if, fortunate for me, I've done so many trig things that I feel like each method is equally the same and easy for me. But right now, probably adding up to 180 is the best way. So probably most of you found angle J first. I decided to find side G first and use sine of 39 degrees. Even though 51 degrees is easy to figure out and is the right answer, okay, I would probably, when solving, it's nice whenever possible to use all of the sides and angles that were given in the question, because you have a less chance of having made a mistake and then using that mistake to find something else. So I found that G was 14.3 centimeters, rounded to the nearest tenth, because that's what the question says. And then I used a squared plus b squared equals c squared to find J. A couple of things about your calculator, okay? If you have the newest version of your calculator and you want something like 14.3 again, you can use the arrow up key like this and highlight it and push enter, and it comes up again. If you have an older version of the calculator, that option isn't available. So when you get an answer, like I solved for 14.3 first, and I'm thinking maybe I want to use that later, I might use the store button, and I might store that answer, and I might choose alpha G, the letter G, because that's what it was and what it stood for. Then if you later on, so you do some more math, 5 times 5, 3 plus 6, all these hard ones, 2 plus 1. Oh, I better check that again. Yep. So oh, 6 minus 2, is it 4? Yes. Okay. Let's say you've done a bunch of math, and now you can't even see the 14.3 anymore. I think, yeah, it looks like there might be a few mistakes, but we'll check. Now that you've done all of that math, and you're like, oh, I need to use G again, which was 14.3, if you just go alpha G, it's still there. So that storing button is really nice. And it will remember that G is 14.3 for a very long time. We should put out a challenge. I don't know if they reset the computers in summertime. Sometimes they do. But you should come and check at the end of the year in June. Hey, Mr. JR, let's check what your calculator is set at. See if G is still 14.3. If I've used it for anything else or not. Have I ever used A?
Yes.
No, I haven't.
You've definitely used
What about B?
Maybe it's when you close the program.
Maybe. I don't know if it resets it. We can check. We can check tomorrow if G is still 14.3 or not. Maybe if I close the program, it resets it. Okay. Our last example here says solve the following triangle, and it tells us it's a special triangle. It's an isosceles triangle. What does isosceles triangle mean? Two sides and two angles are the same. Based on the picture, does it look like two sides are 12 or two sides are 8? Okay? So yes, I would agree that it looks like two sides are 8. That would mean that these two angles are the same. Is it a 90-degree triangle?
No.
We don't know. Okay? There's nothing given in this question that says that it is a 90-degree triangle. Okay? And this is what I want you to know. If it's not 90 degrees, you cannot use SOHCAHTOA. SOHCAHTOA is a definition that only works with 90-degree triangles. You can't use a squared plus b squared equals c squared. That only works with a 90-degree triangle. In fact, we can use a squared plus b squared equals c squared to prove that this is not a 90-degree triangle. Let's say you think it is. If you think it is, would you say, I think that this is the angle that's the 90 degrees? And that the 12 would be the hypotenuse? Obviously, the 12 is along this side. So then you would have question mark is 8 squared plus 8 squared equal to 12 squared. Well, 12 squared, question mark here, question mark there, because I can't say they're equal because I don't know. Right? This is actually bad math by saying something equal that's not, but that's why I'll leave the question mark there. Well, this is 144, and this is 64 plus 64, which is 128. The answer is no. 128 does not equal 144. So we can say for sure that this is not a 90-degree angle. We can use angles in a triangle still add up to 180 degrees. If we knew one of the angles, we could find the rest, but we do not. So currently, unless we get creative, we can't solve this triangle. In fact, there's math that you learn next semester in grade 11 that lets you solve. This is what math does, right? You learn some math, you solve a bunch of problems, and then you come into a problem you can't solve. So then you need more math to be able to solve that. So there is something you learn next semester, which is the sine law and the cosine law, which will help you solve triangles like this. At this point, we cannot solve this triangle unless we get creative. Cut it in half. Just a suggestion. How would you like to cut it in half? Like this? As long as the areas are perfectly, is that a good cut in half?
It'll work out.
No, we're not going to cut it in half like that. But what happens if we cut it in half by going straight down here?
You get a right angle triangle.
You get a right angle triangle. And on that right angle triangle, I'm going to go view, zoom, page width. On that right angle triangle, if you cut it in half, you would know this side is 6, this side is 8. For solving the whole triangle, what's going to be important for us? Because if I'm going to use the same letters that are here. No, there are no letters. On this triangle that's cut in half, we know that that's 90 degrees. Can you see that you do not know this angle, you do not know this angle, and we do not know this side? For solving the entire triangle, what should I figure out? I can figure out them all. I can figure out the black one with a squared plus b squared equals c squared. I can figure out the green one using cos. I can figure out the purple one using sine. But based on the original, if we color code the original, this is our black, this was our green, this was our purple. Did I do the right amount of, accuracy here. The green had one line, the purple had two, just to match it up perfectly with what we had before. Which one do you think is going to be most useful for figuring out our big triangle? Yes? The purple angle will be helpful, or the green angle, right? Either of them will be helpful. If you find the purple one, then you can find the green one, and the purple one just doubled will be the whole top one. Okay? So let's say I've got my green pen out. Let's start with green. If I'm finding the green angle, I know SOHCAHTOA, I know the adjacent side and the hypotenuse, so my definition, and I'm going to label this theta, so I have a variable, cos of theta is adjacent over hypotenuse. How do I get rid of the cos out in front? Take the cos inverse of both sides. Go to my calculator. Cos inverse of 6 divided by 8, 41.4 degrees. So if I go back to my original triangle, I erase this extra stuff. That green that I just found out was 41.4 degrees. If I figure out that green one, what else do I know? I know the other one is 41.4 degrees. And you have to add up to 180. These two right now add up to 82.6. So the one at the top, if I do 180 minus 82.6, it'll be 97, or 92, 82.8, sorry. Does that add up to 180? Perfect. So initially, we looked at this and said we cannot solve it. And the only way we were able to solve it was by being creative and making a right angle triangle. Because if it's not 90 degrees, you can't use SOHCAHTOA, and you can't use a squared plus b squared equals c squared. Sometimes in mathematics, when you use something you're not allowed to, like if you're doing an exam and it wasn't a 90-degree triangle and the first thing you did was use something you're not allowed to, that's where the marking would stop. So if your very first step you use something that's not the right thing, chances are you're going to get 0 on that question. So it's important to know when we can use something and when we can't. And if it's not 90 degrees, we can't use this. In this question, we checked, but then when we got creative and split the triangle in half, we made a 90-degree angle, and that allowed us to solve it.